Now it's very relaxed today.
I've been sleeping asleep. I'm sorry. I was feeling actually better after lunch, which is kind of weird because after lunch you would be like,
Heavy, it's true.
yeah. But maybe it helped that I actually moved doing dishes.
Did you help in the cleaning performance?
No, I announced to some people that I can't do this because I was like literally that time I was like really. You saw like me at the workshop, the sound stuff.
Yeah.
In the end, I was just laying down because
Oh, you lay down.
I really couldn't, and I think I told you, like I can't do this or something like that.
Yeah.
But like I was just fading out, and then I just went to sleep because I really couldn't.
Yeah, I mean, nobody's gonna tell you have to do it. As long as you do something else.
Yeah, I mean, I've been doing dishes like hell.
Yeah. Like hell.
Like even I'm in a hell. I died, like the prime minister, and I have all this karma or whatever.
People tell you like, no, wait, but this guy was doing dishes. Hell.
No. Now I'm in hell. That I have to do the dishes all the time because I'm in hell.
Oh, why you're in hell?
Well, because of my behavior in the past life. I don't know.
Oh wow, that's becoming very abstract.
It is.
What are we talking about?
See, it's not working.
Naoto is loco.
It's
Naoto
loquito.
está loco. Naoto está loquito.
Loquito.
So nice. Like I really want to invite like Jean-Michel to the next chat.
Would be nice.
He's really interesting person.
Yeah. We can talk.
He was speaking
Slow.
about something called like non-philosophy. I'd never heard about that. Have you heard of that?
No.
Very interesting. I think the idea in a big scale, I'm just misuse words, is that in a big scale is that there is no reality as such. So no matter what you do, there is nobody. There's that you don't know reality, and you never will get reality. But yet it is, meaning that it's just alien to you. So
Okay.
it is, but you can never experience that.
Okay.
You will find anything that you want around that idea, but reality as a concept of is not such. So this is used as an interface somehow to then take philosophical tools. Meaning that he did an analogy that is very similar how we do the practice with the non-binary in terms of technologies, so queer conversation between technology and bodies. He says that so the way how they approach philosophy is then you take one school at a time and then you analyze it within this rule, understanding that there is no reality, and basically what that allows you is to keep distance from it because you are not in reality. So you bypass the politics if you want to set in what we speak about. You don't compromise yourself with being inside of reality. You take some distance and you can analyze and learn.
Okay.
But you don't get emotional and all these things because you know you are not there.
Okay.
And I think that's at the core what the whole thing is about.
Yeah. Yeah. We need to have chat with him.
Yeah.
But I kind of get
The whole
why part. Like what it is, I don't know, but why you need it, I kind of understand.
the whole conversation started because he said we were speaking about, I don't know what exactly. I said that
Oh shit! It says slow card. Oh, because the data is big. Let's try.
Naoto está loquito.
The problem is like some SD cards, it has problem with 4K because 4K is super big. Like the bandwidth wise also, it has to write a lot in 1 second.
Yeah. It just demands more the battery.
The card, the memory card. If it's not compatible, then it doesn't work.
Ah, yeah, okay, yeah, yeah.
I don't know, to be honest.
But also will consume more power, no?
That too, yeah, of course. Yeah.
Everything bigger, bigger. It's entropy.
But because we were talking about him and he said about 4K, well, he just read 4K on the camera, so let's stick to 4K.
So he said like he's working in a. I think what he does. I asked him. Yeah, I asked him, "Are you a singer?" Because he was singing at the chapel, like
Ah, that was him.
yeah, like
Okay.
really beautiful, as a proper opera singer. And then he said like that he went to school, but nowadays like for maybe 30 years he's working with, and he's interested in financial something calculus with financial things,
Okay.
and he's working with computers for 30 years, and then I was trying to suggest that okay, that has to be with a lot of systems and how when you try to see what happens, no simulation, but what they use a lot in the stock market. You try to foresee the future. That's the name of that in mathematics. It's not calculus. It's a yeah, I cannot remember exactly what it is. It's when you try to foresee things in the future. Yeah, I forgot. Anyway, is that when you're trying to foresee what is going to happen in the future, depending of based on some data you foresee, statistics. And then I was trying to suggest like then from the point of view of development, then like in development, then you will work more with logic. And then he said like no, absolutely no, and he was like really categorical in no. And I was like, wow, okay, but no, how? And he was trying to say something that at the end I got it. His point was his approach is very poetic to code, and but then my lack of knowledge, I guess, in coding is coming through development. So and from things that somehow they're alien to me. Um, then I just was saying that he was saying that coding is actually, for being a good coder, you need to be a good literature. You need to know about literature. You need to know how to write, and that's it. If you know how to write a book, like you can be a good coder. If you know how to write a paper, you can be a good coder, and it has to be nothing with logic.
I see. Yeah, I mean, it's interesting topic because I'm gonna just over generalize this, but it's like a often like misconception that people have to, like, if you want to be a good coder, like you have to know all these logic or algorithm or whatever. Like for example, like this like really easy example is like computer science. If you study computer science, can you be a good coder? That's absolutely not, because that's not, they don't teach you how to code basically, or like how to write good code. The best practices in coding is missing. And but not saying that computer science is bad, it's different thing, that it's very specific thing. Well, maybe again, like easy, if I pick easy example, like these days machine learning, that's in computer science mostly, and you need it to develop new models. But that's not like, if you have a startup, maybe you want to make a new model, but if you just want to make instant profit from like actual projects, looking at real world things, you don't start with building models. You just take someone's model and apply it, and that part is like actual, what, I don't know, 90% or 95 or maybe 99% of what coding is just like building these things that actually runs, and not about proposing something new. And that's probably something like what you were saying about
Development.
Michel, that like development or writing a book, because you have to have some kind of structure. You have to know big picture Maybe I see it like that from the example of book, because if you write a book, you can't just write sentence by sentence, right? I
Right.
mean, that's how it works, but you need an overview.
Right. You need to have a research before writing a book.
And also, just looking at the structure wise, it has to have the structure, and someone has to know the whole thing,
Right.
right? I mean, even if it's like different chapters and compiled, there's someone compiling, editing, who has the overview, and that's the same with the programming, because you have different components, and like, yeah, it has to work in harmony in some sense, and that's completely like different. That is a practice, and that's not something that they teach in computer science, or like they study in or research in computer science.
Which has to be more with the subject of like what I will mention as a topological problem, or like the fact that basically you have to think really well, conceptualize a lot what is it you want to do. So it has to be more with a qualitative approach in the way how you want to start working on something.
I think it's quite convoluted problem, because I wouldn't say no completely, because it is obviously like this structure is qualitative for sure, because it's not like you need how many pages of introduction, and like it's something that you can put numbers on it, like it really depends, but also some kind of, I don't know, depending on the type of the book, probably you have, or like if you look at research article, then it's really obvious that you start with the background, and then literature review, and methodology, and this is kind of already set. So that's true, but then there's another layer of like actually implementing that
Okay.
qualitative
Yeah.
thing. That's more like hands-on, and that's why I'm saying practice, because it's something to be learned from practice.
Yeah. That's what, like, we were talking with Thomas a bit of. By the way, I don't know if you know, like Thomas has a very nice. I haven't seen. That's a pity, but I have heard that it's a very nice performance about Go. Uh, Thomas is a director and he writes also his pieces. Um, he's one of the teachers of theater of parts.
Ah, okay.
Of theater, yeah, parts. And so I think his plot is it goes around on the moment that the machine won in this in Go. I think it goes around that, and I have heard like many comments of like really good reviews about it.
Interesting.
And then why I was mentioning Thomas because in relation to the chaos theory workshop, he was mentioning that he's developing now a piece on chaos theory, which he's taking his personal loss of his father. That's the plot. But then within that, then he's just using then analogies of nature and loss to to portray then chaos theory. And then in relation to the chaos theory workshop, he was saying that he's missing, and that perhaps that I would agree with this, that we are missing more examples of nature where you can find a lot where chaos is all the time.
See.
Because then the workshop stays a lot in the theory and sometimes in the mathematics or in the theoretical part, and that's why we have sometimes these loops of questions of people asking why this letter you forgot to put. I mean, is people who don't really know or don't have the fundamentals of this, like we don't have the fundamentals of mathematics to go so deep into such a complex subject, and then you're trying to grasp everything, and that's very complicated.
Yeah, basically you have to go to the university. That's what I'm saying.
That's what it does, exactly.
And that's what I did. No, but I get. I understand both. Like, I get why Thomas is saying, and also why Manuel is teaching that way, because, like what you said, yeah, I think it makes sense, and it's always good to have like real world examples to understand things. But also that's gets very tricky, because if it's the tricky thing of real world examples is that it's limited to, well, quite limited to this Newtonian physics, because that's
Right.
what happens. And
Yeah.
then if you want to say, okay, quantum mechanics and blah
Yeah.
blah, which is not
Yeah.
the topic of this, but like then, if you want analogy, there's no analogy, and that's the really like problematic thing. Like, for example, also this Schrodinger's cat, like
Yeah,
if the
yeah,
cat is dead or not.
yeah.
People misunderstand this, like people just make wrong ideas around it, because it's actually not something, it's not something explained like that.
Yeah, I see what you mean. Yeah.
Yeah, and then I think Manuel's standpoint is that he really wants to go through the theory and not to give wrong ideas. Okay, this is chaos, this is not chaos, I get that point
Yeah,
too.
yeah.
But I also understand that without examples, it's really hard to follow, and it's really like just looking at math. And if you don't have any idea, then it's not really enticing to learn. That's for sure.
No, it's a good point. Yeah. No. Yeah, because if you want to go in quantum physics, then maybe you can record a glass of water.
What?
You can record. You have these experiments when they say like they have been recording, like when you put a glass of water and then you put a note in a glass of water that it says like, I don't know, happiness or sadness or something, and they have some result, like they prove somehow this. So maybe the example that you have is you have a recording of half an hour of the glass of water, and then you say, voila, there's the example in nature of quantum theory.
Yeah. But but the weird thing with quantum mechanics is that we can't see it, but it's always happening. Of course, that's that's what it is. Like our world is constructed like that, and also if you look at like smartphones or whatever computer is using like very specific condition in quantum mechanics that like kind of breaks the like how silicon like devices work, is like really putting to extreme condition by applying voltage and like doing this tunnel effect, which is like rarely happens. Like the probability is really low, but you artificially make this through the silicon chips, and that's how it's calculating, how it's doing computation. And so it's everywhere, this weird quantum mechanics theory like that. I don't know, like I can't really remember, but that's happening everywhere, although we just don't notice. And it's so frustrating that you can't really explain. It's not like there's this heat source and that's agitating the molecules and becomes
that
hot.
happens in thermodynamics.
Yeah, it's not like that. It's like this hole and there's electron and they recombine and emits energy, like. But that's what it is.
And it happens. It happened.
It's happening.
It's happening.
It's like.
Yes.
So actually, I wrote to John that art and science is hard. So I don't know. I sent a photo of the blackboard. This is what we're doing in France. Like, yeah, because it's hard. It's hard.
Yeah.
Anyways. So I don't know. We're gonna summarize the workshop.
So we summarize the workshop. We have been 2 days, no? 2 days of workshop so far.
The whole, yeah,
2 days of
the main lecture.
lectures.
2 days.
So I think there is 2 more to go.
Yeah.
And so I think now we can summarize. I can summarize the chaos theory.
What is chaos?
Chaos theory is actually very chaotic. And you need a slope. Not always, but you need slope in some models, which can be an analogy with an ass.
An ass or
An
ass?
ass, like the ass. If you have underwear, you have a slope. You can predict the tangent of the underwear because it's not a line, but it's a curve,
It's a curve,
right?
yeah.
But then you can then predict the slope of the tangent. What space?
State space?
Yeah.
Yeah.
So you need that. So what I'm saying is you need one of the ways where you can approach chaos theory is like with an ass and some underwear that it covers half of the ass. You cannot do it with boxers. You need to just cover like briefs that it allows this curve to happen.
Stretch you.
Yeah.
True.
Yeah. So that's my take on chaos theory. What can you say about chaos theory, Naoto?
I don't know. I I can't say anything more interesting than that. But yeah. But actually, I had vague understanding of it before coming here, and I think it was correct because I always look at this Lorentz attractor, which is it's like mathematical. Or, I don't know equations, and there's always like if you learn processing, there's a good example by Dan Schiffman, and yeah, he made a simple sketch of the Lorentz attractor. I've used it before. I mean, edited it before to just make some nice drawing diagram with that equation. And that's basically it. It's just like it's a set of equations in the program. It's not changing because it's in the program, but you can't predict what it's going to do. But it's in a sense that it's like drawing something. It's not like just exploding elsewhere, but it's drawing. You can draw it, but in a fashion that it's not like always doing the same thing. It's like kind of unpredictable, but
it goes in the same path. I mean, it
not necessarily.
Yeah, but not, what I meant is like, wait, so it's not the same path, but it uses the vectors in a similar way.
Yeah, it's kind of constrained.
Yeah,
it kind of moves in a it looks random, but it's always coming back.
Yeah. Yeah, it will. Yeah, because it's not about random. It will move within constraints. Yeah, true.
And it's also like very simple equations. I mean, it doesn't have to be simple, but it's the equations are set. It's not like the parameters.
That I found interesting. I mean, that I think that allowed me to access the information a bit more, because you have to just know that.
Yeah. So it works well with programming, and also like Manuel is doing this visualization and stuff. It goes well because you can write down and program and just run it, and it does something unpredictable.
And wait, a question, like, do you, like, there's something that I stop my brain trying to understand because it's very complicated. Like, I didn't understand the difference between, like, variables and parameters from programming. I mean, what is the difference in the topic that we are speaking? Because that's something I didn't understand. Because from my head is still in programming with that.
Mutable and immutable, let's say.
What?
Is it the word?
Yeah.
Like in JavaScript.
In Java, you have that
JavaScript you have
Yeah.
let and const,
Yeah.
and let's say parameters are const and variables are let.
Oh wow. In the topic that we're speaking.
Yeah, yeah.
Oh wow. But this, yeah, okay, that's a bit confusing because I still in my head I'm trying to separating, and also I put in arguments, so variables, parameters, arguments.
I mean that's really oversimplifying, but it is.
So constants are parameters,
Yeah,
and then variables are lets.
yeah,
Okay, no, that's a good analogy. So constant, like, so then parameters are immutable, like a fixed
yeah,
point.
yeah. So that's a fixed point. It's a fixed value.
That's a fixed value.
Fixed point means it's something else now.
Yeah, but it's a fixed value. Yeah,
Yeah.
like a fixed value.
Yeah.
Yeah.
But of course, then, if you look at the other diagram that has the state space with different parameters, so parameters, in that case, you change the parameter.
But it just doesn't change. It's not changing the path. Depending on the model, will change the path. The path.
It will, yeah. But even in that case, the idea is that the parameter,
Yeah.
is in that one session, you change the variable.
The
Because it's
variable.
always change the variable with static number of the parameter, and you
Yeah.
do something and you get the result, you get the topological structure or fixed point or whatever within the same parameter, fixed const parameter,
Yeah.
and then you move on to another parameter to evaluate again.
After that, yeah. That's why it's linear.
I don't know if it's linear or not. That's why.
But it's only after you get that point, that solution, that you get moved to the next one.
Yeah.
Yeah.
So the variables
Yeah.
in different sessions, they have nothing to do with them. Like variables are
Yeah.
always changing in one session, let's say, to draw the state space.
Yeah.
Yeah, and then you change slightly the parameter, evaluate it with, changing the variable. So it's like a for loop within for loop.
Yeah. Yeah. That I got. That they were like in capsules.
Yeah.
Yeah.
Yeah. Yeah, it's hard.
No, but then the way how you like to explain, I think is like because I think you touch different things there. Yeah.
Yeah.
Yeah. I think it's simplified. Yeah. But how about this saddle? I didn't got like this the saddle point.
Oh, saddle point is
Because attractors or repulsor are self-explanatory.
yeah, it's because then it's the saddle point is hard to imagine like as a kind of because attractor and the repeller as an analogy it's quite self-explanatory, like you said. But saddle points they're not because it's kind of doing nothing.
In
But-
terms of the attraction of repulsion.
Exactly.
Okay.
Because what happens?
It's just there. And
yeah, because
but anyway, there is. I mean, somebody decide that is there anyway.
I mean, it's only obvious if you draw these curves of fx, because depending on the slope, right? Like the cross section, if it's like I don't know this way or this way, that decides repeller
Yeah.
attractor. But what happens is like it kind of crosses, so it's obvious if it's like going this way or going this way, then it's obvious. But then sometimes it happens like it's almost like touching the like cross section is like not going this way, but it's like touching, and then the curve goes down again.
Yeah.
So actually, the slope is 0,
Yeah.
or like this is possible too, and so there in that diagram there is a point
Yeah.
where there is a cross section, but if you look at the vector field,
Yeah.
the vector doesn't change,
True.
or at least it goes 0. But like if you look at the property as a attractor or
It
repeller,
doesn't
do
work.
anything.
No.
Yeah.
Yeah.
But the important thing is like that happens when you change the parameter and the repeller and attractor. You can see that like with parameter, like changing the parameter, they kind of come closer, because what happens is like if you have this curve, you have this negative slope and positive slope, so you have repeller and attractor, and then if the curve, like if you take some parameter that makes the curve like going down and down and down, then what happens is like these 2 points coming closer and closer and closer, and then at one point they merge.
Which never happened in cross.
So there is cross section, but it's just like touching. So it's not like crossing, but it's like they kind of go like this. It's not like penetrating. So that's really specific.
Again, the saddle.
That's a saddle point.
Okay.
But yeah, I mean, you can see it as like it's not like attractor or repeller, but it's just like a specific point. It means something when you look at the parameters. Only look at the parameters. But if you look at the variables,
it won't change. It won't change.
Really
Yeah, it won't change. Nothing. Yeah.
Yeah.
It's significant.
Yeah.
All right. So I think we should close this because there is a recap, but maybe I'm not sure.
We just did the recap.
Yeah, I was thinking that maybe I'm not gonna do the recap, but maybe I would like to go for a walk.
That'd be nice. Yeah.
Wanna go for a walk?
I will rest a bit.
I think I'm gonna go for a walk.
Yeah, that's a good idea. I wanted to, but I'm not sure if I do it now. No.
I probably should work in that letter, but I need to write 2 letters now. Because after the whole let's close this.
Close.
Yeah.
Thank you for watching.
Thank you for watching.
Please like the video, subscribe to my channel, and write the comments.
Who the fuck are you?
Bye.